what I'm saying is that you are creating voids because again, remember, the idea is something like if I have a quantum state and it's and look, I'm trying to build a quantum computer. What you don't want is decoherence. So what is decoherence? Decoherence is the process of having your quantum state interact with the environment, entangling to it, and then losing information. And so what's happening when you create a quantum state is you are setting up some sort of physical apparatus, the thing that creates the quantum state. And then you're pumping energy into it.
Yes.
And this process then creates your quantum state. And generally you want to create a pure quantum state. Like you want to do
Yeah.
quantum computing with pure states.
Yeah.
And
So
so,
it's useful.
huh?
So that it's useful.
Yeah, so that's useful. Well, it's like you're trying to create a pure quantum state, which all everything that we've gone through, a pure quantum state means it's separable. So you're erasing the correlations, you're removing correlations. If
Yes. Yes.
decoherence creates correlations, then creating a quantum state removes correlations. And so what you have is an object, but then you have this thing called a wave function, right? And the wave function is supposed to describe the quantum state, this thing that you've created, this void you've created. And so for me, the question then became, all right, if I have this wave function that describes the state, but the state itself is separable, this wave function that has information that I can use to predict the future with. And so the question I would started having is what is the wave function versus what is the state? The wave function is your information that you have about the void because of your knowledge of the physical apparatus that you use to create the void.
Okay. So the information is not lost, is what you're saying. It just transformed, is what we can say.
What
Kind of.
I'm saying is something like the wave function has information about the state because of your knowledge of the classical apparatus that you use to
Exactly.
create
Yeah.
the
Yeah.
state.
Yeah. Yeah. That's what I'm saying.
Because this quantum state, if it's pure, has no correlations to the environment. So part of my issue I had is that if I have correlations, then I have the capacity to predict the future. So if the quantum state has the capacity to make inferences about what I'll measure, then it seems as though there's correlations here between the system and the environment, and that's captured in the quantum state. But that's not the case. What's happening is that I set up my physical apparatus, I know its settings, it then creates the void by removing correlations, and then what I have left is the quantum state because of my knowledge of the apparatus, because of my knowledge of the settings of the apparatus, that I now know what this void is. But the void itself, if it's actually pure, is completely separated from the environment.
Okay.